This Working Scientist podcast series is sponsored by the University of Queensland, where research is addressing some of the world's most challenging and complex problems. Take your research further at UQ. Visit uq.edu.au.
Hello, this is How to Save Humanity in 17 Goals, a podcast brought to you by Nature Careers in partnership with Nature Food. I am Juliana Gil, Chief Editor at Nature Food. This is the series where we meet the scientists who have been quietly, incrementally working towards the global development targets set by the United Nations in 2015. World leaders pledged to solve a range of economic, environmental, and social issues, and a package of 17 Sustainable Development Goals were born. Since then, in a huge effort, thousands of researchers all over the world have been tackling the biggest problems that the planet faces today. In episode 2, we broach Sustainable Development Goal number 2, Zero Hunger, and meet a researcher who looks to the oceans rather than land-based agriculture in an attempt to achieve this aim.
My name is Christopher Golden. I'm an associate professor of nutrition and planetary health at the Harvard T.H. Chan School of Public Health. My background is in ecology and epidemiology, and I study the human health impacts of environmental change. Most of my research is oriented around food systems and the ways in which environmental change has impacts on these food systems, and within that, I have a particular area of interest in looking at aquatic foods or blue foods in the ways that they could pave the way to a healthy and sustainable diet. Sustainable Development Goal 2 is about creating a world free of hunger, and the idea here is to ensure that everyone has adequate food intake or food insecurity. The degree to which I think about that in my own work is that this is certainly the closest thematic area to the types of work that I do in terms of the ways that our research really is aiming to achieve the Sustainable Development Goals. With that said, the overarching theme of Sustainable Development Goal holds true for my research, but it is still limited in scope in that it focuses on hunger. My team's research tends to focus a bit more on what is termed hidden hunger, or the types of hunger that underlies food insecurity, where we really think about micronutrient deficiencies, which are things like iron, zinc, vitamins A, vitamin B12, fatty acids, whereas hunger is truly defined as inadequate energy intake or inadequate overall food intake. And we really think about food quality in the terms of the work that I do. Blue foods, or kind of as I call them, aquatic foods, are any sort of food that comes from marine or freshwater environments. And so this includes all of the fin fish that you might be thinking of, like tuna and swordfish and snapper, but also all of the invertebrates or mollusks, so things like clams and mussels and oysters and octopus and squid. In addition, we also include aquatic plants, so all of the seaweed and different types of algae that are consumed globally. There's probably more than 3,000 different taxa that come from marine and freshwater environments that are currently consumed as food. And although they are not often thought of when we think of the food system immediately, because there's such an over-focus on agricultural systems or farming techniques on land that produce our food, they are truly underpinning many people's diets around the world. Around the world, blue foods as a livelihood sector are supporting hundreds of millions of people, and the consumption of blue foods are currently pervasive across every country, whether landlocked or not, affecting billions of people around the world. And these foods can help to support the micronutrient nutrition of hundreds of millions of people around the world, and even some estimates are that in the absence of blue foods and diets, roughly 1 billion people might be affected through their nutrition. And so it really forms this kind of critical underpinning of many people's food systems, and in the absence of them would have very harmful impacts on their nutritional well-being. I really believe that blue foods can play a really critical role in paving our way toward healthy and sustainable diets and assisting in achieving Sustainable Development Goal 2, which is aimed at achieving zero hunger or overall nutritional security and well-being. And the reasons for this is that in a recent model that we did, we looked at what would happen when we are able to innovate and increase expanding aquaculture, which is farming fish for food, and also rehabilitating fish stocks and harvesting fish in sustainable ways from wild capture. And when we can increase the productivity of fish by 2030 or by 2050 to peak levels, we're actually able to help fill these micronutrient deficits in a variety of different countries. And so I see them playing really two roles. One is to fill these micronutrient deficits, so providing iron and zinc and vitamins and fatty acids to populations who don't currently have adequate levels of them within their own food system. And the second role that they play is they actually can wean people away from less healthy meats. And so when you have an abundance of blue foods in your food system, people are eating less red meat, less processed meat, which are known to be associated with certain types of communicable disease like obesity, diabetes, different types of cancers, etc., that are kind of unhealthy from a malnutrition standpoint in overnourishment. And so there's kind of simultaneous tackling of undernourishment and overnourishment through the production of blue foods and through the use of them in the food system. I think that blue foods have been neglected in overall food system dialogues because there's been a historical focus on terrestrial food production systems. As we know, we have a very limited amount of arable landmass, or land that is able to have food grown on it. And as populations increase, as environmental changes lead to greater droughts, greater freshwater scarcity, greater soil nutrient depletion, we are running out of space on land to grow an adequate amount of food for food systems globally. And I think that there's been an increasing attention now being played to what marine and freshwater systems can help to produce to complement the overall food system. So although they have been ignored and neglected historically because they have been viewed more as a wild food resource, farming them and creating innovative technologies to help produce aquatic foods has really been instrumental in creating healthy and sustainable diets in many regions across the world. And of course, this is a bit of a kind of Western orientation or global North orientation in thinking about food systems, because for many cultures, many subsistence cultures, many indigenous or First Nation cultures, seafood has played such a critical role for millennia in terms of how they view their food system and this kind of interrelated relationship with nature. When thinking about the environmental impact of blue foods in comparison to terrestrial food production systems, you have to keep in mind that if we're comparing meats to meats or animal source foods to animal source foods, beef comes from one species, chicken comes from one species, pork comes from one species, and blue foods is this entire kind of diversity of different species that is coming from 3,000 different taxa. So we can't think of it as one thing that is produced in one way that has a certain type of environmental impact. There's going to be an entire variation of environmental impacts depending on what species we're looking at, what production system is creating it, where it's being produced, and how it's being fed. And so there's large variability in terms of that answer. What we really need to think about is which blue foods can be more sustainably produced with a lesser environmental impact, while at the same time providing high nutrient supply. And so what we've shown in our work is that when we compare let's say, 15 different categories of blue foods and terrestrial animal source foods. So if we compare kind of large pelagic species, meaning tuna and mackerel and things like that, to small pelagic, sardines, anchovies, to bivalves like mussels and clams, to octopus, to pork, to beef, to lamb, to goat, to chicken, nearly across the board, the nutritional benefits are going to be higher in the blue foods than in the terrestrial foods. So if you look across the nutrient spectrum, blue foods are richer nutritionally. Then if we filter that down to say, okay, which ones can be produced with a lesser environmental impact, these small pelagic fish resources, and so things like sardines, anchovies, and also seaweeds, things like sardines, anchovies, etc., and also many farmed species. So when farming is done right of things like salmon or tilapia, they can have a very, very low environmental footprint. And so when farming is done right, or when wild capture is done right, the environmental footprint is very low. When you think of things like bottom trawling or industrial fishing of that nature, that is very carbon footprint heavy. Or if you think about different fish that have quite a bit of fish meal or fish feed that go into it and it isn't being done efficiently, that is also something that is not environmentally friendly from a food production standpoint. And so there's so many different nuances that go into this answer, which is why I'm having a difficult time answering it succinctly. But to say if we optimize across all of the different features of environmental impact and we optimize across all of the different features of nutritional benefit, blue foods generally fare very well. There are some to steer clear of and some that look very, very good. And I would say as a prime example, things like bivalves, so the oysters, mussels, clams, not only are nutritionally incredibly rich, but they can even be nature positive, meaning that they are filtering contaminants away from the environment. They can be kind of a carbon sink and are not requiring any sort of feed inputs in order to produce themselves. And so that could be seen as kind of a simultaneous environmental and public health co-benefit. The countries that are most at risk are the ones that have a heavy reliance on blue foods currently and are also currently facing food insecurity within their own food system dynamics. And so these are places like countries in West and Central Africa, parts of the Southwest Indian Ocean, South Asia, Southeast Asia, and small island developing states in the Pacific. And so you could think of countries that are particularly at risk like Guinea-Bissau, Ghana, Madagascar, India, Bangladesh, Solomon Islands, different places like that that are going to be most prone to vulnerability given a change in access to seafoods given their current types of nutritional profile. There are certain countries that we need to think of less in kind of a national perspective, and that you can also think of subnational vulnerabilities. And so even developed countries like Canada, that could be a country that overall is not going to be nutritionally vulnerable to the climate impacts or the environmental degradation impacts on access to seafood and food security. But then if you look at particular populations like coastal First Nations of British Columbia or the Canadian Arctic, there are going to be populations that are incredibly vulnerable and sensitive to these sorts of environmental changes that lead to a change in access to seafood. There are so many interventions that could take place to really benefit countries' food security overall, and many of those implemented through blue food pathways. So some ones that come to mind immediately are the implementation of marine protected areas, whether these are locally managed marine areas or marine national parks that help to rehabilitate fish stocks in coastal areas, and then the surplus of that kind of rehabilitated stock will then spill over into coastal areas, creating greater access to food security by people being able to obtain seafood. So that's one. As an example of this, just even ecosystem rehabilitation, so whether this is mangrove conservation or the creation of artificial coral reefs to help extend healthy coral reefs and then rehabilitate fish stocks, anything that helps to kind of rehabilitate the fishery is going to be an intervention that would enable people's increased access to seafood products. We can also think of different trade or policy interventions as being very important. So to ensure that fish that is being produced in nutritionally vulnerable countries is not entirely exported to nutritionally secure countries would be a type of intervention that would be helpful. So to give you an idea of ways that this could play out, distant water fishing fleets that fish for fish meal or fish for different types of migratory resources within the exclusive economic zones of nutritionally vulnerable countries are exporting nearly 100% of that out of those nutritionally insecure areas. And when that happens, you're basically stealing these incredibly nutrient-rich resources from countries that need them most to pad the food system of areas that don't need this from a nutritional dependency perspective. So thinking about the policy implications of what does global bottom trawling look like? What does the global fish meal production industry look like to feed aquaculture? And so with that said, the aquaculture industry is also something that could benefit enormously from limiting the amount of fish meal that goes into their overall fish products. So many companies are doing a great job at this right now, but there's still a lot of variation in terms of how much fish meal companies are using, to what extent they're relying on food grade fish that could be more efficiently used by nutritionally vulnerable countries just to consume that directly. And so we really need to be conscious of how the kind of efficiency and equity dynamics of the aquaculture industry and how food is being produced. There's also a need to prioritize nutrient-rich blue food products in the grand scheme of overall blue foods. And I would say that this is less of an issue as compared to many of these other things that I have discussed from an intervention standpoint. But as an example, let's take Indonesia. Indonesia might be incredibly vitamin A deficient given their current food system. And so in looking at what sorts of fish best deliver on providing vitamin A, that could be something like carp or milkfish or bivalves, and then a focus on optimizing their food system to deliver the types of nutrients that they're lacking could be a really effective intervention to help deliver those. In order to achieve this in many local contexts, what is needed is national guidelines. And so what this is often called are national dietary guidelines that are created for nearly every country on Earth. And integrating blue foods there very purposefully will help to ensure that we're getting these types of nutritional benefits mainstreamed within to the overall food system. Climate change will have very widespread and pervasive impacts on marine and freshwater ecosystems and the ability to access seafood moving forward into the future. So let me give you a few specific examples to really outline the ways in which this might unfold. Climate change will increase ocean sea temperatures, and as that happens, equatorial areas will become warmer and warmer. And in so doing, fish, because they're not fenced into a particular location, will migrate poleward. And so as that happens, there will be less and less fish catch available in these equatorial or tropical areas. And these are the very areas that we are worried most about from a food insecurity perspective. And so as these resources are moving toward the poles, they're moving away from the people who need them the most. Secondly, you could think of an impact of climate change being ocean acidification or increasing thermal stress on particularly vulnerable marine environments. And so one of my postdocs is leading a paper right now looking at the impacts of thermal stress on coral reef environments, the impacts on biomass that will have through events like coral bleaching that then reduce people's access to seafood in coastal subsistence and very often indigenous cultural systems, having major impacts on people's nutritional security. In addition to just overall seafood access, we can't forget about food safety issues. So as climate change is increasing temperatures on land and sea, maintaining a cold chain for different types of food products is going to be increasingly challenging. And so increased prevalence of certain types of bacteria, viruses, and other types of pathogens will become hyper-prevalent in the near future. The subsequent impact on health from increasing climate change that will then destabilize fisheries, limit people's access to seafood, and increase people's micronutrient deficiencies will be very widespread across the world. So we will have increasing rates of micronutrient deficiencies in things like iron, zinc, selenium, vitamin A, vitamin B12, fatty acids. And we have estimated that upwards of hundreds of millions of people will be affected simply through climate change, limiting people's access to seafood products. When that happens, we can't think of these nutrients as kind of occurring in isolation or that being the end game of the health impact. Deficiencies in zinc will lead to increasing rates of diarrheal illness and impacts on immunity that will lead to child and maternal mortality. We will also have impacts on vitamin A deficiencies leading to kind of similar immunity impacts. Iron deficiency leads to anemia and prenatal and perinatal mortality for mothers and infants, leading to kind of increased maternal hemorrhage and other events like that. So each one of these micronutrient deficiencies has an associated health impact that doesn't simply sit within the nutritional domain, but has massive kind of knockdown effects on both morbidity and mortality. I think that the best way to move forward as a society is to become increasingly conscious of what we eat and to put this in this sort of planetary health frame of how can we eat to best protect ourselves and our planet. And I do see that blue foods can really pave the way toward healthy and sustainable diets. And so thinking carefully about the dietary decisions that you're making is one method to really improve the health of the planet and the health of yourself.
Thanks for listening to this series, How to Save Humanity in 17 Goals. Join us again next week when we look at Sustainable Development Goal number 3, how to ensure good health and well-being for all. See you then.
This Working Scientist podcast series is sponsored by the University of Queensland, where research is addressing some of the world's most challenging and complex problems. Take your research further at UQ. Visit uq.edu.au.